Everybody, we are going to now focus on the vertical shifts of trigonometric functions, but we're going to focus on sine and cosine. Those are the most common. The other ones are not as common, but we're going to just focus on the vertical shift. We've already talked about the amplitude here. Okay, that's the amplitude, and we've already investigated how, what that exactly is with a sine and cosine wave. And then we talked about period, and that kind of like squeezed it in like an accordion or stretched it out, like a slinky. All right. We haven't talked about C, and he's going to be a separate video. This one actually is going to be a short video because it's going to focus on the D. Okay. Now you notice here what's critical about the D here is that the D needs to be outside of the parentheses. So if you do not see parentheses, then it is automatically a vertical shift. Okay, for example, if I have something like y equals the sine of theta plus 4, okay, the 4 is D, it's not C. All right, if I go like this, that 4 just became a C, okay, because a value in the parentheses needs to be the C. And if there are no parentheses, then the D is basically just an add-on. All right, and that's kind of convenient because the C is probably the most difficult of all four. All right, so what we want to do is we want to be able to do all four in one shot. But let's just focus on D for just this video. So let's say that I have y equals, let's go just plain old sine, just to focus on the very basic shift in our D, okay, our D parameter. All right, let's say that, let's label our axis here 1, -1, that's 2, and that's -2. Let's say that I have the sine plus 1. Okay, I don't have any parentheses, so the 1 is D. All right, so this means that with a vertical shift of +1, it's just like the other functions, any kind of transformation of other polynomials and exponential functions and quadratics and lines. All right, this is basically an upshift of 1. Okay, so we take the whole sine curve and we just lift the whole thing up by 1. But one of the things that I want you to do, though, is when you start these very complex ones, when you've got 4 things going on, what you want to do is you actually want to do the D first because he's your baseline. All right, now I think I called this the node in the last videos. It might actually be called the mode. I should have looked it up, but it's essentially the average. All right, it's the average sine or cosine value is right along the middle. Okay, so what happens then is since the whole sine curve is going to be shifted up 1, what I'm going to do is I'm going to actually go up 1, but I know that sine actually starts at 0. Okay, cosine starts at 1. So if you remember our generic sine and cosine waves, okay, they go like this, okay, and that's from 0 to 2 pi. Cosine goes like this, starts at the +1 and actually ends at +1, and right in the middle he's at his lowest. Okay, so if you just remember those 2 basic shapes for sine and cosine, it doesn't matter sine, cosine. If this was cosine, it's just you just have a different, you start at a different value. All right, so this means then for the sine, I'm going to focus on this shape. This whole thing is going to be lifted up 1. And so I go to 1, and I know that at pi, he actually should have been at 0, but since we're lifting it up by 1, we go to 1. And then at 2 pi, he also hit 0, but since we shifted it up 1, we go here. Now what we do then is you don't have to bother thinking about the rest of it too much, because what we're going to do is we're going to draw a dotted line. Okay, and now we're going to focus on this being the quote-unquote x-axis. This is our new baseline, okay? And so now we're going to do a generic sine wave that passes through this right here, okay? And what's nice about this is that when you have the other things going on, like an A, a B, and a C, you're going to look at this baseline where you shift and lift things, okay, or squeeze things together. You're just going to look at the dotted line, okay? Now it looks like here 1 unit is actually two values here. So when I go to the middle here, I actually go up 2. That's a difference of 1 here. And then over here at 3 pi over 2, that's when sine is at its minimum. So he's going to go 2 units here. So the sine wave here has actually been completely lifted up 1 unit. Okay? All right, and that's going to be very valuable for when we get into applications of these things. We'll see if we actually have enough time to do that by the end of the year. It's so short on time. We're going so slow. Okay. All right, now let's throw in a cosine. Now I'm going to go y equals cosine of theta. And let's go minus 2. Okay, we're going to go minus 2. And you can see there's no parentheses, so that negative 2 is not a c. All right. All right, so looks like then, since cosines, well, we're going to go 1, 2, 3, negative 1, negative 2, negative 3. Might as well go 4. Okay. All right, so if the whole thing is going to drop 2, now his baseline was at 0, but since we're dropping 2, I'm going to negative 2, and I'm going to draw my center line. Okay, you can call it a center line instead of a node or a mode. I forget which one. Okay, now here I'm going to recreate the cosine pattern, but I'm going to go 2 steps down. So I go, looks like I always start at cosine at the top of his wave, okay, at the crest, okay. Then all the way at 2 pi, he reaches his crest again. And in the very middle, this is where he actually reaches his lowest, okay. And notice here that this is an amplitude of 1. I had an amplitude of 1 over here too. I didn't change that, okay. In fact, our next example, what are we on time here? I don't know. You know, if the amplitude would change, I would do it from the baseline, okay, from that center line. All right, so I know in the middle he actually hits 0, and he hits the 0 here. So cosine theta minus 2 looks like this. Okay. Okay, I'm going to do one more real quick. Let's go y equals, let's go 3 sine theta plus 1. Okay, plus 1. Okay, so 3 sine theta plus 1. Now I'm simultaneously doing an A and a D. Okay, so I see that the positive 1 is here outside of parentheses, so this means I go to positive 1, and I'm going to draw my baseline there. It's a sine curve, so I know that he will start at 0, in the middle hit 0, and at the end hit 0, or I should say no longer 0, it's a baseline. Okay, so I'm going to have here, here, and here. So I know he's going to hit that. Okay, but now what's different now, the 3 means it's an amplitude. So an amplitude of 3 means that from the baseline, okay, from the baseline, I'm going to be going up 3 units. All right, so instead of hitting 1 here, as I normally would do, I would actually have 3. Instead of hitting negative 1 here, I'm actually going to hit negative 3. 1, 2, 3. Okay, so notice that this is the amplitude from the baseline here. The baseline has shifted up. Okay, the whole thing shifted up. And so now I just go ahead and graph it like I normally would. Okay. All right, so there's no changes in the period. We didn't have any change in B. We didn't have a C. C is for the next video. Okay, so right now I'm going to stop. I'm going to give you guys 12 of these. All right, they're going to start with just the first 6 will just be vertical shifts, and then the next 6 will actually be amplitudes and vertical shifts. Okay, and I'll actually go ahead and give you the answer key to see how you're doing as well. All right, okay, I'll stop right there. Have a good day.